Hello everyone. Now we'll start with the next model of cloud computing. As you can see here, in the next model of cloud computing, there are 5 essential characteristics of the cloud computing: broad network access, rapid elasticity, measured services, on-demand services, and resource pooling. These are the 5 essential characteristics of cloud computing. Then there are three service models: software as a service, SaaS; password platform as a service, PaaS; infrastructure as a service, IaaS. Then there are 3 deployment models: public, private, hybrid, and community. Then now we'll go over these 5 essential characteristics. These are like reserving and traveling in a train. You can have access to the train from whichever station you can get. Similar to that, cloud provides broad network access. You can access cloud through internet, through standard computers, desktop, laptops, mobile devices. From any application, traditional or cloud-based software can be installed. Then comes the rapid elasticity. Just like in the train, they can shrink the train, or based on the demand, they can add some new cars to the train. Cloud also provides this elasticity where you can scale up or scale down your infrastructure. So for example, if you have low traffic, you can have 1 or 2 servers, but if you have a lot of traffic, then you can add new servers easily and quickly, automatically. Then comes the measured services. Similar to the train, you buy the ticket only for the portion of the train where you are traveling. So cloud also provides measured services where you pay only what you use. So if you use the server for say 1 hour or 2 hours, you pay only for the time or the usage you had. The next characteristic is on-demand self-service. Just like in a train, you would book the ticket from wherever you want. In cloud, consumer can provision, they can register, they can automatically provision the services from wherever they want. And on demand, there is no need for any manual intervention or human interaction. Then the next one is resource pooling. For example, in the train, everybody goes together and therefore the services are shared. The train consumption is shared. So similar to that, all the resources are shared. That's why the multi-tenant model helps, because the storage, the compute, the network, they all are shared. And this really helps the cloud because the resources, at some time, somebody may be using high resources, their usage will be high. For other person, it may be low. So based on the resource pooling of the resources, everybody is benefited. So that's what I was telling before, that multi-tenancy is supported by resource pooling, and resource pooling is supported by multi-tenancy. However, since they are multi-tenant, we need to make sure that they are isolated. The visibility is from one client to another client is not there. They are truly segmented. So these are the enablers for the multi-tenancy model, and it provides the ability to resource the pool. So we need the policy driven enforcement, who can access and who can do what and where, truly segmented environment from one client to another, isolation, one client's environment is totally isolated from the next. There is governance. We have a whole CCM on control and governance based at service levels. The cloud should have a very high availability. When any tenant wants to spin up any server, it should be highly available. And charge back and milling model, that's the measured service. As much as one client use, they pay for that compute or storage or network. So it really helps the resource pooling and multi-tenancy go hand in hand. Then this is the cloud service model, how the SaaS, PaaS, and IaaS work together. So I'll start from the bottom, which is infrastructure as a service. So actual facilities, computers, hardware, network devices, walls, electricity, all those things are responsibility of the cloud provider. The core connectivity and delivery, and they are accessed through APIs. So you do not log into the actual hardware. Rather, these infrastructure as a service is provided through APIs. Then next is the platform as a service, which is on top of infrastructure as a service. And we'll go over that in detail too. Then on the top of it is the software as a service. So let's look a little more in details at infrastructure as a service. So provisioning, processing, storage, network, and making sure that there is enough cooling in this facility is secured, the physical security, the hardware, abstraction, connectivity, etc. is the responsibility of the provider. That's infrastructure as a service, and as I said, these services are offered through APIs. So the user of infrastructure as a service just calls these APIs. And this is the architecture of a simplified infrastructure as a service. There are computers. Then there is hypervisor. Hypervisors helps have those compute resource pooled, and on the top of them is VMs that are managed by these hypervisor. The abstraction is provided by the hypervisor. Here there is a pool of storage. Again, the management and orchestration is done by virtualization. That is the volume controller, storage volume controller, and this is the compute controller. And this infrastructure as a service can be accessed from outside the world, which is through internet and by using those APIs that are provided by the cloud provider. And next layer is platform as a service. Again, these are accessed by the APIs. This layer accesses the infrastructure as a service. Most of the time, these are application development framework, middleware, application development and running platforms, consumer created or acquired software developed by the consumer or purchase software, etc. For example, VMware or Cloud Foundry, Pivotal Cloud Foundry, those are the examples of platform as a service. And they can be created using the programming languages, Java, Python, whatever the cloud providers support, they will provide those services. So that's the platform as a service. A typical PaaS architecture is here. This is your infrastructure as a service layer. On the top of that application platform is installed, and on the top of that is the application development environment or application running environment. Again, this can be accessed from internet using the APIs provided by this layer. And as I gave the example, PCF, Pivotal, Cloud Foundry, etc. are good examples for platform as a service. And the topmost layer, if we are looking in the vertical model, software as a service. It can be installed on IaaS or PaaS, or it can be offered as a data center service, but it could be installed in a data center but offer software as a service. It still has the characteristic of the cloud computing. In this case, data, metadata, content, application, APIs, everything is managed by the provider. Presentation modality, platform, everything is managed by the provider. Consumer can access through through internet, but they do not manage the APIs. They do not manage the metadata or the storage or the compute or how application is running. They do not manage the running application, but they are able to manage their access control. They have to manage who can access and how can they access, role-based access or attribute-based access, etc. Now, this is a simplified software as a service architecture. This is a database layer. There is a NoSQL PaaS layer where this is the database layer. Next is the application server layer. This is a 3-layer model, typical 3-layer model. And last is the web server. All this is managed by the service provider, and user can access it through internet and there is a load balancer here in front of the web server. There is load balancer in front of the application server, and there is a controller in front of the virtualization controller in front of the database bases. This is a typical SaaS architecture. Now we are looking at those 4 cloud deployment model, and we'll go over detail. So cloud deployment models and where does the responsibility lies in each. So in the public cloud infrastructure is managed by third party. It's a public cloud, and it is off premise. It can never be on premise. It is somewhere there. You access through internet, and it is untrusted because everybody is allowed. Whoever can register and pay, they are allowed to register and pay on the public cloud infrastructure, and therefore it is supposed to be untrusted. The private cloud it could be either within organization or it could be provided by a third party. It could be on premise or it could be off premise. However, it is provision for one organization. It is provision for you. That's why it's supposed to be trusted. The same for community. Community is like for common interest. If there is a cloud made for common interest, for example, if there is a cloud provision for organizations that are financial organizations, or there is a cloud for federal government, for example, FedRAMP certified. It could be a third-party provider hosted, or it could be within the organization. It could be off-premise or on-premise, but whichever way it is hosted is trusted, because one financial organization trust, or the parties that are accessing, they are known, they can trust each other. It's a known entities. That's the community. The hybrid is a hybrid of a public and one in the middle, either public and private or public and community. It's hybrid. It is managed by both organization and third party provider. It could be partially on premise, it could be partially off premise, and of course the one which is on premise is trusted and which is off premise is untrusted. So in the hybrid cloud, again this is a model of hybrid cloud. The public cloud is there and private cloud or legacy infrastructure is there, and it could be used as a legacy access or control through the VPN, etc. It could be used for cloud busting. Cloud busting is when additional compute or there is a sudden increase in the traffic, then you could start using the public cloud. So it could be a standard or proprietary public cloud which could be accessed through the direct connect, VPN, or through internet, and that could be used for cloud busting or legacy access. Now let's look at the logical model of the cloud. So there are 4 layers, starting from infrastructure, that's the bottom. It is the compute, it is the core compute and storage core infrastructure. Then next is the meta structure, which is the hypervisor and the management plane. Next is the appli structure, which is application and services. And infrastructure is the data and the information layer. That's the logical model of the cloud computing. Then comes the shared responsibility model. This is a typical infrastructure as a cloud, infrastructure as a service, shared responsibility model. In this, the physical infrastructure, the virtualization, the hypervisor and abstraction model layer, abstraction components, etc., and application and PaaS services are the responsibility of the service provider, while the security of the server and host, this is again infrastructure as a service model, where host, server, security, etc. is consumer's responsibility. Provisioning of network, IAM, access management, etc. The meta structure components and configurations and security, all that is consumer's responsibility. Data and application security is also consumer's responsibility, and this will change when you go to a typical PaaS or typical SaaS. But this is a typical infrastructure as a service model whose responsibility is more. And this is very important to understand who is responsible for what. If you take an infrastructure as a service, it doesn't mean that it's all fully secure. The cloud provider they cannot secure your, say for example, your server EC2 instance, because they have no visibility, and they should not have any visibility on your database or your server if they are providing infrastructure as a service. And of course, the management plane, part of the management is done by the consumer, where you will spin, you will create a network interfaces, etc. But the abstraction layer and management plane is responsibility of the provider. And here is the last slide. how does the responsibility changes from infrastructure as a service to the software as a service. The lower we go, lowest is infrastructure and highest is software. So the lower we are, mostly consumer responsibility. And as we go higher, it's mostly provider's responsibility. As we saw that in software as a service, the provider provides the platform, the server, it's their responsibility to secure the web server, app server, and provide you the service, software as a service, the application as a service. So that's how the the responsibility increases, and this is very important to understand when you migrate to cloud. What is your responsibility as a consumer? And with this, I think we will close.